Welcome to the continuation of growth and development. So we have looked at introduction, we have looked at growth and growth in plants, and we also started germination. So we're going to continue with germination till we finish it. In the next video, we'll look at growth in animals. So we're going to take a look at the conditions that are necessary for germination. What conditions are necessary for germination? So the conditions necessary for germination of seeds include oxygen, water or moisture, and temperature. And by temperature, it has to be a suitable temperature, not a high temperature, not a low temperature. So we're going to spend a few minutes from now just doing experiments, trying to see how we can justify or how we can show that oxygen is necessary for photosynthesis. We're also going to do the same for water and temperature. So let's take a look at the first experiment, which is going to be centered on oxygen. So I want to see that I want to see if oxygen is necessary for germination of seeds. So we're going to have these two setups. So whenever we are doing an experiment, there is the actual experiment where we think things are going to work as the theory states. Then the other one is called a control experiment, where we're going to make some adjustments which can disprove what we expect. So the one that is used to just to test if or to disprove our expectations is called a control experiment. Okay, so in this case we have a stopper here, we have a string, we have a cotton wool which has seeds attached to it. Okay, so then here we have water. So the three conditions for germination are temperature, water, and oxygen. So in this case, we are assuming the temperature is a suitable temperature. There is also a presence of water somewhere, and there's oxygen here. We can't rule out that there's no oxygen here. No. Then in the control experiment, we have a stopper. We have the same, everything the same, but instead of water, we have this solution called alkaline pyrogallo. So alkaline pyrogallo absorbs oxygen, just like the way sodium hydroxide was absorbing carbon dioxide in those photosynthesis experiment. Here we have alkaline pyrogallo, which absorbs oxygen. So here there's no oxygen, here there's oxygen. So if you leave this setup for some time, you're going to discover that seeds here are going to germinate, while seeds here are not going to germinate, which proves that oxygen is necessary for germination of seeds. Next, we look at experiments to show that water is necessary for germination. So we're going to have this setup using petri dishes. So we're going to have some seeds on this petri dish. We're going to label it as A. We're going to have another petri dish. We're going to label it as B. We're going to have another petri dish. We're going to label as C. So on A, we're going to make sure that A has no water. Then on B, we're going to put water. We're going to make sure that the seed is surrounded by a lot of water. Then on B, we're going to get a wet cotton wool, and we're going to just to put it here, and we'll keep on sprinkling this clothing here so that it is always wet. The idea is to make sure that there is suitable amount of water here, not too much, not too less. So we're going to make sure that there is always a bit of water here. Well, here we've put a lot of water. Then here we're going to leave it the way it is without water. So what's going to happen is, after some time, the seed in here are not going to germinate. Why? Because too much water is bad for germination. It can make the seed to rot. Therefore, no germination can occur. Then here we're going to see some, first we go to this one where again we want to see some germination because there's no water. So no water is provided for them to soften the tester and activate enzymes. So what water does is it makes the tester soft. If the tester is soft, the plume and the radical can break the tester and they can germinate. But if there's no water, the tester will be hard for the plume and the radical to break free. Okay, so here now where there is a good amount of water, we're going to experience germination. Okay, so water is necessary for germination. Why? Because it makes the plume soft and also activates some enzymes. Then for oxygen, I forgot to mention, for oxygen, why is it necessary for germination? So oxygen is used in respiration. So a seed is going to make sure that there is respiration when there is oxygen. Oxygen will make sure that there is respiration in the seed. When there is respiration, energy is going to be released. Remember, respiration releases energy. This energy is the energy that the plume and the radicle are going to use for the plume to sprout from the ground and for the radicle to go deep into the ground. So that's the importance of oxygen. It makes sure that respiration occurs in a seed. This respiration produces energy. This energy is used by the seed to germinate, in short. So in summary, water softens the tester so that it can split to release the plume and the radicle. It activates enzyme and provides an aqueous medium for metabolic reactions to take place. It is also involved in hydrolysis of complex nutrients in a seed. Okay, so because of water, starch can be broken to maltose so that maltose is used by the seed. So the third factor that is necessary for germination is temperature. So here we're going to use some expensive equipment just to demonstrate. So we're going to have a fridge. We're going to have just a petri dish here, and we're going to have the same petri dish, but it's going to be put in an oven. And also in this fridge, we'll assume that we have put one. So we're going to have a petri dish with water and of course oxygen, but in a fridge. Then here we're going to have just a normal petri dish with oxygen, water. We're going to assume there is water here and right temperature. Then here all the conditions the same, but temperature here it's in an oven. So in an oven we're going to make sure that we set the temperature to be very high. So once the temperature is set very high, we can see which ones are going to germinate, the ones inside here, the ones here, and the ones here. So here the temperature is too low, 0 degrees Celsius. Here the temperature is too high, maybe above 100 degrees Celsius. Then okay, that's too much, but anyway, well, let's assume a high temperature in here. Then here it's going to be a normal temperature, that is the room temperature. So where do we expect germination? Here, not here, and not here. Why? The reason is here enzymes are not active at low temperature. This is a fact we know. Okay, then here enzymes, because of the high temperature, are denatured. So because enzymes are denatured, they cannot do metabolic reactions that are going to facilitate germination. Then here enzymes are active at optimum temperature. Okay, so we're going to close this with types of germination and maybe one or two concepts after this. So there are two types of germination. There's what is called epigeo germination and hypogeo germination. So epigeo germination, this is a type of germination where the cotyledon are pushed above the ground by elongation of the hypocotyl. Remember the hypocotyl. So as it is elongating, it's going to push the cotyledon above the ground. So the sprouting shoot is going to have a cotyledon on top of it. So it will be like this. So this is a cotyledon which is above the ground, and the plume is going to have this hooked shape. Okay, so this is the hypocotyl that has elongated. Okay, so the radicle and the root hairs are going to be down there, and the tester is going to be discarded from since now the seed the test has been broken. Okay, so just to take a look at this stage by stage, we can take a look at this. Okay, so the regions are just near the regions near the radical and the plume is the epicotyl and the hypocotyl. So what's going to happen? We're going to start from here. So we have the radical here. So what's going to happen is the hypocotyl will come out. As the hypocotyl is coming out, the root will go this direction, but the hypocotyl is going to break the ground. So once it breaks the ground, it will use the cotyledon to break. So the cotyledon will come here on top, and the tester of course will fall off. The hypocotyl will keep on elongating here. Okay, and the leaves are going to come from the plume as shown here, or the cotyledon will just be here. So this is epigeal germination. Next is the hypogeal germination, which is the type of germination where the cotyledons remain underground due to elongation of the epicotyl. So this is the epicotyl that elongates, making the cotyledon to remain under the ground. Okay. So the plume is covered with a sheath, which we discussed, called the coleoptile, which protects it from the abrasion as it pushes out of the soil. So it protects it from the mechanical damage as it is pushing out from the soil. Okay, so this is how hypogeal looks. So the coleoptile, as you can see, it's here covering the plume. Okay, the cotyledon and others are going to be down here, and we have these shoots, roots, which are called adventitious roots. Okay, but what is important is the fact that the cotyledon remains on the ground, the coleoptile and the plume comes out. The coleoptile here, the job is to make sure that it protects the plume from damage. So if we go here where we look at it step by step, we have a seed coat here. The radicle here will be developing into roots. Okay, the hypocotyl will be here. Then the epicotyl is going to elongate. So as the epicotyl is elongating, or the coleoptile, once it breaks free from the ground, it's going to be here. Then the epicotyl, inside it there is a plume which is going to develop into the leaves. Okay, so the main difference is the cotyledon remains on the ground in hypogeal, while in epigeal the cotyledon comes from the ground. The other difference is the hypogeal is facilitated by the elongation of the epicotyl, while epigeal by the elongation of the hypocotyl. So now we look at something easy to comprehend, that is seed dormance. So seed dormance is the state or condition during which a seed carries out minimum metabolism and does not germinate. So you can have a seed, you can throw it maybe on the ground, but it won't germinate. Why? Maybe because it is not doing a lot of metabolism, so it won't germinate. Okay, so that condition is called seed dormance. So what's the importance of seed dormance? It is important in the following ways. One, it gives time for the seed to reach full maturity. Two, it prevents the seed from germinating when conditions are not favorable or are harsh. So when the conditions, maybe there's too much sunlight which can destroy the shoot, so the seed would be in dormance. Also, it gives time for other parts of the seed to grow. Okay. So what can cause seed dormancy? Some of the causes of course I've mentioned them, but let's take a look at some of the common causes of seed dormance. So sometimes the tester can just be too hard for the plume and the radicle to break free from. So this can cause dormancy. Then sometimes it can be chemical substances that are in the environment. So some seed embryos have hormones such as abscisic acid which keep them from germinating. So this chemical called abscisic acid is going to to make it difficult for the seed to germinate if it is of a certain level. Then sometimes it can be physiological conditions. So some plants and seeds can only germinate if first exposed to certain conditions on the environment, such as cold temperature, light, or darkness. So this can cause dormancy. So now, in a situation where your seeds are in dormancy, but you want them to start germinating, what can you do? So these are some ways in which you can break dormancy. First, you can do scarification, which is just the physical destruction of the hard tester so that a seed becomes permeable to water and oxygen. So you get a seed, you make sure that the tester has a scar so that water and oxygen can penetrate through the inside of the seed. There is also soaking seeds in water. So this softens the hard tester in some seeds. There's also exposure to fire. So the resistant taste of some seeds are only made permeable to water and oxygen through burning them. Also, exposure to appropriate environmental conditions such as light, darkness, and cold temperatures. So some seeds, maybe when they're in darkness, that's when they can experience germination. So you make sure that they are put in darkness or light or cold temperatures. Finally, exposure to appropriate chemical substances which reverse the effects of chemical inhibitors of germination. Okay, so for those for a dominance which is facilitated by some chemicals such as abscisic acid, if you can give the seed some chemicals which can reverse the effect of such chemicals, I mean the chemicals that facilitate dominance, then you can break dominance. Sorry, dormance. I keep on saying dominance. Dominance is something else. Dormance. Finally, seed viability. So seed viability is the ability of a seed to germinate into a seedling. Okay, so this is just a measure of the ability of a seed to germinate into a seedling. So sometimes, if you are given a seed, its viability can be reduced by prolonged periods of storage. So if you overstore it, the viability of it to develop into a seedling can be reduced. If it has been exposed to high temperatures, or if it is in conditions that have high temperatures, its viability can be reduced, just like the way temperature can have an effect on dormance. Also, if it is physically damaged. Also, parasites and pests can also affect or reduce viability. So these are some of the factors that can reduce seed viability. In case next time you become a farmer, think of these factors. So this marks the end of part 2 of growth and development. In the next and last video, we're going to take a look at growth and development in animals.